Hi guys, so yesterday we were finishing off talking about how we can take a name and turn it into a formula. So we ended off with part F, okay, where we were looking at the different metals that have multiple oxidation states, and we represent their oxidation states in Roman numeral form next to it. So you're supposed to complete 1 through 9. So when we were doing this, right, number 1 we have copper. Copper is represented by what symbol? Cu, okay, and then this 2 means that there is a 2+ oxidation state. And then chlorine is represented by what symbol? Cl, and what's its oxidation state? Should be -1, okay, and so we are going to swap and drop the oxidation states, and remember the charges do not come with them. Copper is going to get this 1 right here, and then chlorine is going to get this 2 from copper. So you should have gotten Cu, Cl2. Okay. Are there any questions over the process of doing this? Okay, this should have been review. Alright, so then let's look at 2. Alright, 2 we have cobalt-3 nitride, and cobalt-3 nitride we know is written CON as your final formula. Okay. So what I'm going to do is I'm going to go ahead and list the answers, and then we're going to look at the ones that you did not do well on. All right. Number 3 should have been FeP. Number 4 should have been V2O3. Number 5, you should have gotten SnS2. Number 6, CrI6. Number 7, TiBr3. Number 8, you should have gotten MnF3. And number 9, you should have gotten NiO. Questions? Yes? Number 5. So this is usually the biggest one that I have an issue with. So number 5, it says I have tin 4 sulfide. So I know tin is represented by Sn, and it had a 4 Roman numeral, so it had a 4 oxidation state. And sulfide has an oxidation state of 2- always. So I still swap and drop like normal. Sn is going to get this 2 as its subscript, and sulfur is going to get this 4 as its subscript. But remember when we were talking about your notes yesterday that when we were looking at ionic compounds, it has to be in its simplest ratio. So that means that I have to look at the subscripts, and the subscripts are both divisible by what? 2. So I'm going to divide each one by 2, and it simplifies to SnS2. Okay? No problem. Questions? All right. Yes, and I. Number 6. So chromium, if you look, chromium has a 6 next to it. Remember, V is 5 and then one more 6. So Cr with a 6+ or a +6 charge. And then I'm going to have iodine, which always has a -1 charge. When I swap and drop those, I'm going to get Cr, and it gets a 1 from iodine. Iodine gets that 6. Okay, usually it's just not knowing the Roman numeral symbol. Okay? Anything else? Alright, so we are going to move on from creating formulas, and now we're going to work backward from formulas to naming overall. Okay, so go ahead and get your notes out from yesterday, or you should already have your notes out, and look at this bottom part right here on the back. Right, so this is what I call your cheat sheet or your rules. Right, writing names for ionic compounds. Step 1, we are going to write the name of the positive ion. 2, we are going to write the root name of the negative ion, unless it's polyatomic, and the root is the first part of the element's name. Okay, 3rd, if it's monatomic, we're going to change the ending to "ide", so oxygen becomes oxide, phosphorus, phosphide. And then 4th, we are going to see if the cation has multiple oxidation states and account for those oxidation states using Roman numerals like we see here. So we have iron 2 oxide and iron 3 oxide. Right. just as a refresher, remember monatomic means what? One what? One atom or one element we're looking at. So this is anything that comes off of the periodic table. Whereas polyatomic means what? Okay, so two or more or many elements working together, and we find this where? On the back of our periodic table, okay? Alright, so we're going to go through and do the simpler or the straightforward naming problems first. So we're going to look at potassium and then the one with sodium. So K, I'm going to first write the positive ion. Which one's my positive ion in K and I? Potassium, right? Okay, everybody know that potassium creates a positive ion. It forms a +1 charge. So I'm going to write the name of my positive cation. Second, it says write the root name of the negative ion unless it's polyatomic. Is iodine by itself polyatomic? No, right? Because it comes straight off of the periodic table. So I am going to write its root word and change the ending to I. So iodine will become iodide. Okay? So usually these are a little bit more simple. Alright, now I'm looking at sodium. Sodium, of course, is my positive cation. In the second step, I'm going to write my negative ion, which is sulfur, and I'm going to change its ending to what? Sulfide. Okay. And so the trick to this is that you just follow these steps. With anything that's coming straight off the periodic table, it's very simple. These are what we call binary compounds because they only have two elements that are involved. Okay? So with these, it's pretty straightforward. So taking a brief break before we move on to the more difficult problems, we are going to look at your unit sheet, Part C. All right, Part C, it's the same concept as those two examples. So I want you to take a moment and do the odds, and then we will come back together and go over them to make sure you're on the right path. Alright, so just as a reminder, looking at this periodic table right here, right, this is on Google Classroom, but I told you it's a great idea to have it organized, okay, so right here I have in purple my oxidation states that we have to memorize, and then remember silver has 1, cadmium has 2, and zinc has 2. Okay, the biggest thing though is when you are doing ionic compounds, it involves a metal and it involves a non-metal. And you should know by now, and I'm going to draw it just in case, you have a metalloid stair step right here. Okay? Anything to the left of it is considered a metal, and they are going to have positive charges. Right? The only one that has a positive charge on the right side of this stair step is boron. So boron, and then all of these over here are positive. So that is the first one that I named. Okay, and when you name it, you're going to represent it with a uppercase letter, and then when you do your second element, that's usually a non-metal, which is on the right side of the periodic table. That's our anions. Those are our negative elements. Okay, so just to apply what I said, looking at Na2S, we've already done that in the example. We know that is sodium sulfide. But if we look at number 3, we have MgO. Which one is supposed to be my positive ion? Magnesium. So this is my positive, which means oxygen is my negative because it's on the right side of my metalloid stair step. So I'm going to first name my positive ion. So that's magnesium. It stays the same. And then next, I'm going to name my anion. We know my anion is oxygen, and I just changed the ending from oxygen to oxide. And it does not need Roman numerals because it only has one possible oxidation state. Alright, so let's look at 5 through 11. Alright, so step 1, we are going to name our positive cation. What is our positive cation here? Potassium is our positive, so we are going to keep it as its original name. And then what's our anion? Okay, so it's bromine, and we change the ending to bromide. Okay, and I double check to make sure that it doesn't have multiple oxidation states. If you go back and look at your notes from earlier, you can see potassium, because it falls in column 1, will always have a +1, so I do not need a Roman numeral. So this is it for 5. Number 7, which one is going to be my positive ion? Strontium, so I'm going to keep it the same. What is my negative ion? Phosphorus, and so I change it to phosphide. Good. Right, and strontium is in my first 2 columns. Strontium will always have a +2 oxidation state, so no Roman numeral is necessary. Number 9, what is my positive ion? Calcium. And what is my anion? Chlorine, so it changes to chloride. Okay. And so that is it. Calcium is in my second column, which means it's always going to have a +2 oxidation state. Lastly, aluminum. Okay, that is my positive ion. Okay, and sulfur becomes sulfide. Okay, any questions over this? Okay, this is the easier form of creating your ionic nomenclature, which is also another word for naming. Alright, looking at the second type of ionic naming, go back to this cheat sheet and look at this third example. I have PBO. We still follow the same steps, but now we are going to have additional things added to it. So if I have Pb as my positive cation, I know that Pb is what? Lead. So I'm going to write lead, and then I write my anion like steps 2 says. What's my anion? Oxygen, which becomes oxide. Alright, so now I'm looking at the last step. If the cation has multiple oxidation numbers, so these are our transition metals and the metals on the right of the periodic table, then we're going to have to indicate their oxidation number by a Roman numeral. Okay, so in all of this, you can see that my transition metals start right here at group 3 and end right here. Okay, zinc always has a +2, cadmium always has a +2, and silver always has a +1. These right here do not get Roman numerals. The rest of the transition metals do. And then that cheat sheet told you that most of the metals on the right side of the periodic table also has Roman numerals. Right? So what's happening is I have my stair step right here. And usually most of the stuff underneath the stair step will have a transition metal. Or not transition metal, a oxidation state with Roman numerals. Thank you, Mason. So aluminum has a set amount. It's always +3. Okay, and gallium usually is a +3 as well. To be able to tell which one should have multiple oxidation states, I can look at the back of my periodic table. Okay, and I can see that titanium, platinum, bismuth, antimony, arsenic, and then all of these are transition metals, are going to have multiple oxidation states. So that means that over here, arsenic will get a Roman numeral, antimony, tin, lead, bismuth, and then usually indium, thallium, and polonium will also get Roman numerals along with the transition metals, but we do not use thallium, bismuth, and polonium that much. So some of you are asking, why do I have sticky notes on my periodic table? They will not be there forever, but first block needed to see it visually. The ones that have sticky notes on it do not get Roman numerals next to their name. And then columns 1 and columns 2 also don't get Roman numerals by their name. So that was just a visual for us to work through problems together. Alright, it's the same thing that I wrote here, except now I have actually circled the different metals that require a Roman numeral next to it. Okay, so questions over this. So as I can see here, lead right here falls under one that I have multiple oxidation states. So to answer this question here, yes, I do need Roman numerals. So I'm going to put a parentheses here, planning for my Roman numerals. And what we are going to do is we are going to use a reverse swap and drop. So I see that both of them have subscripts of 1. So I'm going to reverse swap and drop, which means I'm going to swap them and make them rise as exponents again. Lead is going to have a 1 or a +1 charge. Oxygen is going to have a -1 charge. Alright, what I do after this is I check my nonmetal and see if the nonmetal's oxidation state is correct. Is oxygen supposed to have a -1 oxidation state? No, it's supposed to have what oxidation state? A -2. So I have to multiply both oxidation states by 2 to correct oxygen. So now lead is 2+ and oxygen is 2-. So that means I'm going to put a 2 as my Roman numeral for lead. Right? Another way to see it is if you changed oxygen to its proper oxidation state, I can see that when I add up +1 and -2, what would my charge be? +1 plus -2, I would be stuck with a -1 charge. What is my charge supposed to be when I'm working with ionic compounds? 0. Okay, it's supposed to be neutral. And so that's explaining why we can't just change oxygen and not change lead. Questions over this? Yes, I'm posting this video on Google Classroom literally after you walk out my door. So let's go back to your unit sheet and practice together for a little bit. Okay? Look at part E. Alright, we are going to do the odds. Number 1, we have CuCl. So we're going to still follow the same steps, and then we'll add the additional steps at the end. Alright, what is my positive ion? Copper. So I'm going to write copper with a capital C. What is my anion? Chlorine. So it's going to change to what? Chloride. Alright. Looking at copper on my periodic table, I can see that copper is considered a transition metal, so it's going to get a Roman numeral. So I'm going to put parentheses in between so I can make sure I add that Roman numeral. So now I am going to reverse swap and drop. I'm going to bring it down here so I have more room. Alright, both of them don't show subscripts, which means we consider their subscript to be 1. So when I reverse the swap and drop, I'm going to use a different color. Alright, this one comes up here, so chlorine is now +1, or not +1, sorry, -1, and copper is going to be a +1. The last step is we check to see if the non-metal is going to have the correct oxidation state. Does chlorine normally have a -1 oxidation state? Yes. So I can keep it the same. I don't have to multiply the oxidation states by anything, so I'm going to keep copper as an oxidation state of 1. Alright, a way to check this is if you just look at the name and write it down as you see it, it will check your work. So copper 1, that means Cu plus. Chlorine, we know always has a -1 charge. I swap and drop and it gives me CuCl. Okay, so these two are the same thing. So I did this correctly. Okay, questions over number 1. I'm going to do one more with you and then you guys are going to practice the rest of the odds. Looking at number 3, I have Ni2, S3. What is my cation name? Nickel. Alright, what is my anion name? Sulfur. which is going to be sulfide. Alright, does nickel need Roman numerals? Yes, because it's a what? It's a transition metal. Alright, so now that I have it set up, I'm going to take this down here, and I'm going to reverse my swap and drop. So now sulfur is getting this 2 with a 2 negative, and nickel is getting this 3 as a 3 positive. Lastly, I'm going to check to see if my anion has the correct oxidation state. What is sulfur's oxidation state normally? -2. Okay? And so remember, that's something you have to memorize. So sulfur has its correct oxidation state, so I don't have to do anything further. Nickel is going to have this 3 as its oxidation state. Alright? So, I want you to take a moment and I want you to do 5, 7, 9, and 11. Alright, so looking at number 5, as we've already said, the cation is platinum. So I write that name. And then the anion is fluorine, so I make it fluoride. I'm going to move it kind of down here since I write so big. Alright, we know that this needs a Roman numeral because it's a transition metal. I am going to work backwards. Alright, so if there is no subscript here, that means there is a 1 atom of platinum. So when I reverse it, this is going this way. Fluorine will have a -1. Platinum will get a +4. Okay, and so does fluorine normally have a -1 oxidation state? Yes, so now I'm going to make platinum's oxidation state of 4. Okay, for those of you who do not know, you need to memorize the Roman numerals. This is 1, 2, 3, 4, 5, and then 6 should be the last one that we use. Okay? Alright, number 7, which one is my positive ion? Arsenic. Right, which one is my anion? Oxygen, which turns into oxide. Alright, does arsenic need Roman numerals? Yes, on the back of your periodic table it shows you arsenic can either form a 3 or a 5 oxidation state. Alright, so it does need Roman numerals. I'll put parentheses here. And so I'm going to take this and reverse swap and drop. So now this 2 goes in and becomes oxygen's 2 negative oxidation state. This 5 comes up to arsenic and becomes a -5. So does oxygen normally have a -2 oxidation state? Yes, so that means I can keep this +5 as arsenic's oxidation state. Number 9, what is my cation? Cobalt. What's my anion? Nitrogen, which becomes what? Right, does cobalt need Roman numerals? Yes. Okay, so reverse swap and drop. Cobalt is going to now get this 2, +2. Nitrogen's going to get this 3. It's a -3. So does nitrogen normally have a -3? Yes, so that means I'm going to keep this 2 as cobalt's oxidation state. Alright, and then lastly, FeO. What is my cation? Iron. What is my anion?
Oxygen.
So it becomes oxide. And then does it need a Roman numeral?
Yes.
Yes, iron is a transition metal. So I'm going to work backwards. FeO, they don't have subscripts, so that means it's 1 and 1. So that means when I reverse the swap and drop, it's going to be a +1 for iron, a -1 for oxygen. I check my non-metal. Is my non-metal matched with its correct oxidation state?
No.
No. What is the oxidation state of oxygen? -2, so I have to multiply both oxidation states by 2, and when I do that I get Fe2 plus O2 negative, so that means I'm going to put a 2 right here for iron. Questions? Alright, so we are going to go over the last type of Ionic nomenclature or ionic naming. Go ahead and look at the last problem on your cheat sheet. Alright, so I am still following the same steps for this. Alright, I write the cation. What's my cation?
Magnesium.
And then for step 2, it says write the root name of the negative ion unless it's polyatomic. Is my anion polyatomic? Yes. Okay, so I know magnesium is just one. That's my metal. So then this whole other part is going to be my anion, SO4. And so if it contains more than one element that is on the periodic table, that's polyatomic. So for polyatomic ions, I keep the name as is. Okay? So magnesium, SO4. If I look at the back of my periodic table, it's going to be sulfate. So I will keep that name. This is magnesium sulfate. Alright, I double check to see if the cation has multiple oxidation states. Magnesium is within the first 2 columns, my alkaline earth metals, and so it only has one oxidation state. So no, I don't need Roman numerals. Magnesium sulfate is my final answer. Questions over this? Yes?
So I think sulfate and it's SO4 is a subscript and then -2 is an exponent. So what can we do with the -2?
Nothing. That's the oxidation state. That's how you form formulas. Okay. So when I write this again, Mg is 2 plus, sulfate is SO4 -2, and when I swapped and dropped it, these are going to end up simplifying to 1, and it gives you that MgSO4. So the negative charges on the polyatomic ions are there just for forming formulas. Alright, so that being said, let's look at the last section on your unit sheet. Part G. Alright, Part G, number 1. We have FeBrO3 with a 3 on the outside. First off, what is my cation? Iron. What is my anion? So it's this BrO3. I look on the back of my periodic table. It is bromate. Okay. And so now I have to ask myself, do I need Roman numerals?
Yes.
Yes, because I have iron, which is a transition metal. So I'm going to put parentheses in between. And now I'm going to work backwards. Alright, iron has this 1 right here, moves up and creates a -1, and this 3 comes up here and becomes a positive 3. So now I have to check my anion. Okay, BrO3, does it normally have a -1? It should. So BrO3, -1 oxidation state, so that means that this is good, and I can keep this 3 as iron's oxidation state. So this is a combination of transition metals and now polyatomic ions. Alright, last one we're going to do together before you practice a few on your own. Number 3, I have CrMnO4 with a 2 on the outside of the parentheses. What is my cation? Chromium. And what is my anion? Where would I find this? On the back of your periodic table. So I look on the back of your periodic table. Okay, so it is called permanganate. So it's this one right here. So I am going to write permanganate.
Wait, where do you see that?
Number 7.
Oh, I see it.
Alright, and so then now I have to ask myself, does chromium require Roman numerals? Yes, because it is considered a transition metal. Alright, so I do the reverse swap and drop, okay? CR has a 1 next to it since no number is written, so now this CR1 is going to give a -1 oxidation state to permanganate, and then this 2 is going to go to chromium and become a +2. Permanganate normally has a -1 oxidation state, so that's good, which means we're going to keep that 2 oxidation state for chromium. So to write this in its ionic nomenclature, we would put chromium 2 permanganate. Questions? Alright, so go ahead and look at numbers 5, 7, 9, and 11 and complete those, and we will go over them in about 4 or 5 minutes. Looking at number 5, what is my positive cation? Potassium, so I write its name. Alright, what is my anion? So NO3 is nitrate on the back of your periodic table. Alright, does potassium need a Roman numeral? No, so this is my final name. Alright, looking at number 7, what is my cation? Calcium. Alright, so that means SO4 is my anion. What is SO4? Sulfate. And does calcium need a Roman numeral? No, it only has 1 oxidation state. Alright, so that's my final answer. Number 9, what is my cation? Cobalt. Okay, which means the remainder is my anion. What is CO3? This is carbonate. Alright, will cobalt need Roman numerals?
Yes.
Yes, because it is considered a transition metal. So I'm going to reverse swap and drop, okay? This 2 now becomes the oxidation state of CO3. This 3 now becomes the oxidation state of cobalt. Alright, I look at my anion. Is my anion using the correct oxidation state? Yes, CO3 normally has a -2. Okay, so that means I can use this 3 as cobalt's oxidation state. So that's good. Alright, and then lastly, I have CuNO3 too. What is my not oxidation state. What is my cation? What is my anion? Nitrate. Right, does copper need Roman numerals? Yes. So I am going to reverse swap and drop. So this 2 now goes to copper as a +2. This 1 right here goes to nitrate, -1. Does nitrate normally have a -1 oxidation state? So looking here, I should see nitrate down here, as a -1. So that means yes, this is correct, which means I will use this 2 as my Roman numeral. Alright? Questions? Alright, so what I want you to do is I want you to get your Chromebook out, and I am going to post a practice.